So, hello everyone, I'm Antonio from the University of Padua. And today I will present you I hope, easy to use tool for investigating prediction in perceptual decision making. Now, I had prepared a real life example, but actually Dr. Pezzullo anticipated me for describing what is perceptual decision making. Then I prepared the slide about the most common task about perceptual decision making, but actually Roy anticipated me, so I'm lucky. I can say I'm very lucky, and I want just to say, yes, this is the random dot motion task, or a kind of random dot motion task, and participants usually what have to do? Have to respond to the leftward or rightward direction of dots moving coherently toward right or toward the left within a background noise. And I think the drift diffusion model, or the diffusion models, are one of the most common frameworks for analyzing this kind of data, so for analyzing the choices and the response time. And they assume that a decision maker accumulates evidence, can be sensory or decision evidence, through a sort of, we can call it a random walk process, towards one of two boundary, and when it's one of the two boundary, they select the corresponding response. Now, until now, I've talked about noise, sensory noise, and indeed also from that definition, you can see how the previous research mostly focused on how signal-to-noise ratio influence perceptual decision making. However, this is insufficient, so the likelihood of sensory evidence is insufficient for those theoretical frameworks that assume that the brain is a predictive machine. So according, for example, for the Bayesian brain hypothesis, perception is an inferential act, and the decision maker tries to infer the true hidden state, so the environmental hidden states that caused the sensory inputs, and these inferred states then can be used for influencing my response, for influencing my action. Now, if I specify a model for describing a perceptual inference with some learning parameters, and then I specified a response model for describing how I generate that response and how that response is influenced by the inferred states in the perceptual model, I can use task inputs and the responses of the participants, like, for example, the choice and reaction time, to estimate individual parameters, both perceptual and the response parameters. And that's what we did. We starting from the factorization by Gondam of the Wiener diffusion model, or the Wiener first passage of time, we created a model that could be integrated with the hierarchical Gaussian filter by Matisse. That is is a model that describes variational learning, variational Bayesian learning under uncertainty, environmental volatility, and essentially this model, for the example of the random dot, assume that belief about the dot direction evolves in times as a Gaussian random walk with a step size determined by a learning rate, individual parameter, and the volatility estimated at a higher level. Now, these inferred states then can be used in the response model to influence or estimate how much they influence the three parameters of a drift diffusion model. So the starting point, the drift rate, and the boundary separation. In this way, you can use this tool to really understanding how much at the individual level or at the group level predictions influence the behavior. Prediction influence decision making. So we did some simulation to see whether this model works, and we simulated different scenarios, combining both high and low, mean reaction time, and high and low level of accuracy. And we did the parameter recoveries, and that was very successful in recovering the simulated parameters. Then we did a first attempt to apply this model to a real data set from a random dot-histogram task. And I have to say this was a bit surprising because the model that allowed the drift to be modulated by prediction was the best fitting model. In any case, all the parameters were fitted in a way that you can test whether they are significant or not in modulating, be modulated by prediction. And now we are completing, or we are almost finished to implement also racing models that can be integrated with the hierarchical Gaussian filter, and that is specifically the log normal race model and the race diffusion model. So, take home message: if you believe like me that the brain is a predictive machine, you have to trust that the predictions have a role in perceptual decision making. And I hope that this tool can foster investigation of how predictions influence perceptual decision making. Thank you.